Assalamu alaikum. Welcome to our channel. Learn with MSA.
Me to my database तुमसे ना हो पाएगा और नॉर्मलाइजेशन के बाद मेरा डेटाबेस अपना टाइम आएगा। तो आज हम अपने डेटा को थोड़ी तमीज सिखाएंगे। Basically, we're going to take it from a total mess to a clean, organized design through the process of normalization.
So, here's our game plan for today. First, we'll look at the mess and understand the rules to fix it. Then, we'll go through the cleanup process, step by step. After that, we'll touch on some expert-level stuff. And finally, we'll talk about why any of this actually matters to you.
All right, let's dive right in. Before you can organize any data, you first have to understand the relationships within that data. And these relationships are called functional dependencies. Think of them as the fundamental rules of the game for normalization.
So, what's our ultimate goal? It's something called full functional dependency. It's a fancy term for a simple idea. Every piece of data in a row must depend on the entire primary key, not just a part of it. As you see on the slide, if you know both A and B, only then can you figure out C. You can't get there with just half the information. This is the perfect world we're aiming for. Let's look at this table to make it super clear. To find out a student's grade, you need both their student ID and the course ID, right? If I only give you the student ID, S101, you can't tell me the grade because that student has 2 different grades in 2 different courses. You need the whole key. That's full functional dependency in action. Okay, now let's talk about the problems. The first one is called partial dependency. This happens when an attribute is being lazy and depends on only one part of the key instead of the whole thing. It's like it's freeloading, and this causes a ton of unnecessary repetition in your data. Check this out. The student name, Ali, only depends on the student ID S101. To know his name, you don't need the course ID at all. Because of this, Ali's name is getting repeated for every single course he's enrolled in. It's inefficient, wastes space, and can cause big problems later. And then we have this sneaky little problem called transitive dependency. This is like a chain reaction. It's when a non-key attribute doesn't depend on the primary key directly, but depends on another non-key attribute. So you get this chain. A determines B and B determines C. This is a classic violation of the third normal form and makes updating data a real nightmare. In this example, the head of the department, dept head, is determined by the department ID, DPTID, and the DPTID is determined by the student ID. See that indirect path? The dept head has no direct relationship with the student ID. This is a transitive dependency, and we've got to fix it.
Okay, so now that we've identified all the problems and we know the rules, it's time to roll up our sleeves and start the actual cleanup process. Let's do this step by step.
This right here is our starting point. This is what we call unnormalized form, or just a mess. Look at that courses taken column. We've got multiple courses stuffed into a single cell. Databases absolutely hate this. It's inefficient, hard to search, and just plain wrong. So how do we clean this up? We're going to follow a 3-step process. We'll tackle each problem one by one, starting with first normal form, then moving to second, and finally third normal form. Okay, step 1, first normal form. The rule is simple. Every cell must contain a single atomic value. No more lists. So we break up the courses into separate rows. Great, we solved one problem. But look closely. We've uncovered another one. Now the student name is repeating, which is that partial dependency we just talked about. To get to second normal form, we fix that partial dependency. And how do we do that? We split the table. We create one table just for students, where each student's name is stored only once. And we create another table, student courses, to link the students to their courses. Now, the data redundancy is gone. If we need to change Ali's name, we only have to do it in one single place. Much better. And for our final cleanup step, third normal form, we tackle that transitive dependency. We do the same thing. We split the table again. We create a separate departments table. The benefit here is huge. Think about it. If Dr. Ahmed leaves and a new department head comes in, we only have to update it in one single row in the departments table, not for every single student. This saves us from a massive headache. All right, let's quickly level up and look at an even stricter form of normalization. And then we'll talk about a very interesting topic when you might actually want to intentionally break these rules. So Boyce Codd normal form, or BCNF, is basically a stricter, more hardcore version of 3NF. The simple rule is that for any dependency in your table, the determinant, the thing on the left side of the arrow, has to be a superkey. In this example, if Mr. Khan only teaches Java, then the advisor is determining the subject. But advisor isn't a key, which is a BCNF violation. This is for really complex scenarios where you need absolute, perfect data integrity.
Now for the big question, is normalization always the best choice? Not necessarily. This slide shows you the critical trade-off. Normalization is optimized for data integrity and saving storage space. But sometimes what you really need is raw speed. And for that, we sometimes do the opposite, denormalization. This is common in analytics and big data, where you need to run reports fast and can't wait for the database to join 10 different tables.
So, after all this theory, why should you actually learn this stuff? Why is it so important for your own projects?
Well, it's pretty simple. Normalization reduces data repetition, which saves space and prevents errors. It makes your data way more reliable. It makes updates and deletes a breeze, and most importantly, it helps you build flexible and scalable database designs. For any developer, especially for your final year projects, this isn't just theory. It's the foundation of a solid professional application that won't break during your final demo.
So, I'll leave you with this question to think about. For your next project, what will you prioritize? Will it be pure data integrity, following all the normalization rules, or will it be raw query speed, where you might need to denormalize? There's no single right answer. It completely depends on your project's goals.
If you enjoyed this explainer and found it helpful, please subscribe to our channel if you're new and haven't subscribed yet. And don't forget to like this video. Your support means a lot. Thank you.
Thanks for watching. We'll see you in the next one. Allah Hafiz.